Alright, here we go. We're on Math 2, Unit 4.6, Lesson 6 today, looking at inequalities in one triangle. Alright, this lesson today is not too bad, so I'm expecting probably not a lot of you are going to watch this video. That's alright. Here we go. It says, first of all, we're going to do numbers 2 and 6, and then 10 and 14 on the back side. So it says, list the angles of each triangle in order from smallest to largest. Hey, my quick strategy for this is look at the angle, circle it, draw a line across, and point to that number. So A is 4.4, B I have 3.1, and C goes to 2.7. Just so I'm matching up the right numbers with the right angles. Alright? Now if I want to put them in order from smallest to largest, what's going to happen here is the smallest angle is going to correspond to the smallest side length. So my smallest number happens to be 2.7, so my smallest angle will be C. My next smallest number is 3.1, which goes with angle B. And my last number is 4.4, my largest, angle A. Alright? I just find it real helpful just to draw a quick little line and circle to figure it out. Same thing for number 6. 6 says, list the sides of triangle in order from shortest to longest. Okay? I have a 40 degree here. And because I have 40, 50, 90, what I'm going to do is I'm going to go 40 and go across and say that's my shorty. Okay, I'm going to go my 50 is my medium one, and 90 is my large one. And you might have a different way of labeling. I did small, medium, large, like t-shirt sizes. However you want to do it, doesn't matter to me really. So my smallest side is here, PQ. My medium side is here, QR, and my long side is here at PR. Just my way of going small, medium, large, so I know which side goes to which. Just helpful to draw it. Okay, on the back side we have number 10, and we'll also look at number 14 here. Number 10 is a great one just because it's asking you a question to say, can a triangle have sides with the given lengths? Can I have a triangle with 10, 13, 18, and will it make a triangle or not? It's important to keep this in mind because sometimes you might get line segments together that don't actually make a triangle because one side's not long enough or one side's too long, whatever it might be. The way you solve this is you want to make sure that when you add any two of the numbers together, they are going to be combined greater than, the sum will be greater than the remaining number. So I have a 10, 13, 18. So here's what I would do. I have a 10 plus 13. I want to make sure that number is greater than 18. I also have, which I move down the line, 13 plus 18 needs to be bigger than what's left, 10. And then finally, 18 plus 10 needs to be bigger than 13. So now I just have to check them and see, does it work? 10 plus 13 is 23. Is that bigger than 18? Yes, it is. 13 plus 18, is that bigger than 10? Yep, it sure is. And 18 plus 10 bigger than 13? Yes, it is. So because I can say yes, 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 then I would say yes. This can certainly be a triangle. That's all there is to it. Now, the problems you come into that maybe take a little more work here is when they give you two sides and they say, all right, what is the other possible third side? What could it be? Well, it's the same idea. I'm going to have a number. We can call it x. X plus 13 is going to have to be bigger than whatever's left, 8. But in the same way, that same x value, when I add it to 8, has to be greater than 13. You follow me? So I take my two numbers and I just put them on different sides of the inequality, and now I solve for x. In this case, 13, I subtract 13 from both sides. In this case here, x has to be greater than, well, greater than 5. Well, greater than, it says in this case, negative 5, right? Not going to quite work there. And in this case here, I subtract 8, x has to be greater than 5. That makes more sense there. Okay, so we're in good shape there. X has to be greater than 5. And then, well, if x has to be greater than 5, what else could I do? How could I find another number out? Because that one didn't work out too well. Let me think. Well, there was another way of doing this, right? I could say that, oh, well, let's do this. Let's take our value of 5 and let's plug that in over there. And then we have 5 plus 13. Oh, I know what it is. I'm sorry. Okay, so we'll keep this one. We don't want a negative number. We'll do, then we go, sorry about that. Then we take our numbers we have, 8 plus what we're given, has to be bigger than x. That's what it is. Oh my goodness. So we'll say 21 has to be bigger than x. So we have x is greater than 5, that's okay. And 21 is bigger than x, that's okay. Oh my goodness, what a long day. So what we say is that x has to be greater than 5, and it has to be less than 21. Man, just for that I need to do another one because I really made that one sound a little crazy, didn't I? Sorry about that. Last one. Let's look at 15. Okay? We have 10 and 15. So we could say that x plus, let's see, this time we did the small number, right? X plus this small number has to be equal to 15. We don't want to get a negative number. So we would say that x, greater than, has to be greater than, subtract 10, 5. And then we could also say that 10 plus 15 has to be greater than x. So we get 25 greater than x over here. So x is going to be greater than 5 and less than 25 for number 15. Wish I didn't show you there. So that was a lot faster. Sorry about that. So there's how you do 14 and 15. Boy, it's been a long, long day. All right. Thanks.